Now, we're going to solve an equation which has more than one variable. For x squared minus a squared b to the fourth equals 0. Using the addition property of equality, I will get the additive inverse of a squared b to the fourth and then add it to both sides of the equation. So I will have here 4x squared minus a squared b to the fourth plus a squared b to the fourth equals a squared b to the fourth. And that is using the addition property of equality. Now combining like terms, I will now have this as 0. So what is left is just 4x squared equals a squared b to the fourth. Now using the multiplication property of equality, I'll get the reciprocal or the multiplicative inverse of the numerical coefficient of the quadratic term. Here, x squared. So the numerical coefficient is 4, the reciprocal is 1/4. By distributive property, the left side will just be an x squared. The right side will be a squared b to the fourth all over 4. And then getting the square root of both sides, because there is none that we can simplify. Getting the square root, the left side will be x, the right side will be positive, negative. A squared is a perfect square. B to the fourth is a perfect square, so that will be b squared. All over 4 is a perfect square, it will be 2. The roots are positive, negative, a, b squared all over 2. By checking, I will replace positive a, b squared all over 2 to the original equation. So 4x squared minus a squared b to the fourth equals 0. And then I will have 4 times x is a b squared all over 2 squared minus a squared b to the fourth equals 0. And then squaring this, I will have 4 a squared b to the fourth all over 4 minus a squared b to the fourth equals 0. I can divide this out, and then the product will be a squared b to the fourth minus a squared b to the fourth equals 0. Any number or term minus itself is 0, equals 0. Now what if it is a negative ab squared all over 2? So our equation will be 4 times x is a negative ab squared all over 2 minus a squared b to the fourth equals 0. You have to square this. So 4 times negative is positive. ab squared is a squared b to the fourth, because we have to square this term, all over 4 minus a squared b to the fourth equals 0. Multiplying, we can divide this out, and then this will now be a squared b to the fourth minus a squared b to the fourth equals 0. Any term minus itself is 0. So therefore, our roots are positive, negative, ab squared all over 2. Then, we'll have another example. 90x squared minus 5 is equal to 9x squared plus 31. This is not yet of the form ax squared equals c. But we can rewrite it in the form ax squared equals c if we will just use the addition property of equality, because we are going to remove negative 5 on the left side. And then we are also going to remove 9x squared on the right side. And then combine like terms. So, we'll get the opposite of negative 5, that will be positive 5. Opposite of 9x squared is negative 9x squared. And then the next step will then be 90x squared minus 9x squared minus 5 plus 5. And then the right side will have 9x squared minus 9x squared plus 31 plus 5. Notice that I have added a negative 9x squared on both sides of the equation. I also added positive 5 on both sides of the equation. And that is using the addition property of equality. I have used the additive inverse of negative 5 and 9x squared. So by combining like terms, this will be 81x squared, and this will become 0. And this will become 0 also. And the sum will be 36. Now, using the multiplication property of equality, I will now get the reciprocal or the multiplicative inverse of the numerical coefficient of the quadratic term. The multiplicative inverse is 1 over 81. By distributive property, 1 over 81 times 81 is only x squared, because 81 over 81 is 1. On the right side, it will be 36 over 81. Now, simplify. By simplifying, there's a common factor. 3 plus 6 is 9. 8 plus 1 is 9. Therefore, both numerator and denominator are divisible by 9. 36 divided by 9 is 4. 81 divided by 9 is 9. There's no common factor anymore. So we are going to get the square root of both sides. So this will be x, positive, negative 2 over 3. We're going to check if x is equal to 2 over 3. So the original equation is 90 x squared minus 5 is equal to 9x squared plus 31. Since the value of x is 2/3, I'll substitute it in the original equation. Minus 5 equals 9 times 2/3 squared plus 31. So squaring this, I will have 4 over 9 minus 5 equals 4 over 9 plus 31. So dividing this, I will have here 10 times 4. I will have 40 minus 5. Dividing this, I will have 4 plus 31. And then subtraction, 35. Addition, 35. So that is correct. What if it is a negative 2/3? If x is a negative 2/3, the original equation 90, negative 2/3 squared minus 5 equals 9 times negative 2/3 squared plus 31. Squaring, I will have 4 over 9 minus 5. 4 over 9 plus 31. We can simplify. This will be 10 times 4, 40 minus 5. We can simplify. This will be 1 times 4, 4 plus 31. By subtraction, I will have 35 on the left. By addition, I will have also 35 on the right, which will give us idea that positive negative 2/3 satisfies the quadratic equation.